Okay, so this is part 2. If you don't have this, just do as much as you can on a piece of paper. I know the situation is weird, so I'll accept, if you do some work, I'll accept it, okay? Alright, so this is what you should be doing on, I'm going to help you out with triangle 1. You'll have to do some of it on your own, but I'll help you out with triangle 1 so that way you can do triangle 2. Alright. So, it says graph the following lines and label their intersections as follows. So x equals 5. So I go to x equals 5. 1, 2, 3, 4, 5. Okay. So then that is where I draw my line. This is my line A. Sorry, I'm going to not use that. Oh, here we go. Okay. Now, so label the section of A and B. Oh, we haven't done that yet. Okay, so line A. All right, and then line B. So I graphed that one in blue. Okay, line B is start at 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then my slope is down 3, right 5. So let me make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So down 3, 1, 2, 3, right 5. 1, 2, 3, 4, 5. Down 3, 1, 2, 3, right 5. 1, 2, 3, 4, 5. Down 3, 1, 2, 3, right 5. 1, 2, 3, 4, 5. Okay. And past that, it'll be silly. All right. So let's connect that. All right, so that is line B. So the intersection of line A and B is point K. So intersection of line A and B, so A and B, oh, I didn't even finish that, is point K. All right, so done that. Okay. Now line C, what color have I not used? I'll do gray. So line C is, I start at -2, so it's 1, 2, and then from there I go up 3, right 5. So 1, 2, 3, right 5. 1, 2, 3, 4, 5. Up 3, 1, 2, 3, right 5. 1, 2, 3, 4, 5. 3, 1, 2, 3, 1, 2, 3, 4, 5. Okay, so that's line C. So that's in gray. The intersection of B and C, so intersection of B and C, that's the intersection. That is point J. And then the intersection of C and A, so intersection of C and A is point L. Okay, so now I look and say, find the midpoint of KL. Okay, so KL is here. Now, I can't do the distance, or I can do the midpoint formula, but this one might be easy to count. So because it's vertical. Vertical or horizontal, you can just count. So 1, 2, 3, 4, 5, 6. So divide that by 2 because the midpoint is 3. So 1, 2, 3. So that's the midpoint, and this is label E. Okay, so that point is 5, right? Because A was, yeah. So 5, 1, 2, 3, 4. Okay, now find the midpoint of KJ. So we're going to have to use the midpoint formula for that one because it's diagonal. So if I look, point K is 5. So I'll go right 5 and then up 1, 2, 3, 4, 5, 6, 7. And then J is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. Alright, so when we find the midpoint, remember the midpoint formula is x1 plus x2 over 2, and then y1 plus y2 over 2. So I've got 7.5 and 6.5. I'm sorry. 5.5. Alright, so 7.5, so that's 5, 6, 7, so halfway, and then 5.5. 1, 2, 3, 4, 5, and halfway up. There it is. So 7.5 and 5.5. Woo! Alright, so now Isaac claims that EF is parallel to LJ. Do you agree? So let's make EF okay. Alright, so we want to prove that those are parallel. Alright, how do we do that? We can do the slope formula, or we can try to count. Slope formula, remember, is y2 minus y1 over x2 minus x1. So I can do the slope formula for both of them, which on the test, that's what you're going to need to do. So if you want to practice that, I'm going to count the slope for LJ, and I'll do the slope formula for that one. Okay, so that way we can see both ways. Alright, so from L to J, I go up 1, 2, 3. Oh, that's all. Okay, so I forgot already. So 1, 2, 3, and then right 1, 2, 3, 4, 5. Alright, so then for EF, which I already have those points, I can do the slope formula. So for E and F, so I have y2 minus y1 over x2 minus x1. Alright, so I've got 5.5 minus 4, which is 1.5, and then 7.5 minus 5, which is 2.5. Alright, so we got to make sure that you're like, wait, that's not the same. Remember, we're trying to prove that these slopes are the same because parallel lines have the same slope. Okay? Alright, so 1.5 divided by 2.5. Turn that to a fraction. That is 3/5. So, it says EF is parallel to LJ. Yes, they have the same slope. Okay? Alright, Emma claims that EF is half of LJ. So how do we do that? What does half mean? Well, that means half the length, right? What does length mean? Distance. So you guessed it, distance formula. Alright, so you're going to do the distance of EF, so distance formula is, let's see, EF, we have the points of E and F. So I've got 7.5 minus 5.5, square it. Then I've got 7.5 minus 5, I'm sorry. Then I've got 5.5 minus 4, and square it. So this is the length of EF. So that means I take the points of E and F and I put them in the distance formula. Okay, so we already know that this is 2.5 squared plus 1.5 squared. I'm just going to put that straight up into this doodly. So second square, okay, I'm going to redo that so you can see. So second x squared, okay, then I have 2.5 squared plus 1.5. Ooh, I did put that in parentheses. I mean, it's okay, but it's good practice. Alright, so I get 2.92. Okay, so let's find the length of LJ. Okay, LJ. Did we find the points for LJ? No, we did not. So you have to find the points of LJ. So that is, L is 5, 1. J is, what did we say J was? We didn't, so 6, 7, 8, 9, 10. Oh, we did. 10, 4. Okay, do the distance formula with that. So whatever you get, okay, if you multiply whatever the distance of LJ is by half, you should get this, okay? So see what you get here. Okay, so if you say this times a half gets me this, then yes. Now, it will be rough. So it didn't tell us which one to round to. So it should be roughly half because we're dealing with irrational numbers. So you should agree, okay, explain. So then you would say, I found the distance of LJ, multiply it by half, and I get the length of EF. Find the perimeter of the triangle. So, what triangle, right? So you need to find the perimeter of triangle LKJ. Okay, so you already have the length of LJ here. So then you're going to have to do the length of LK. So that's the perimeter is the length of LJ, which you will find on this part. Then you do the length of LK, which you can count, right? We counted 6 earlier, right? 1, 2, 3, 4, 5, 6. So LK. Which is 6 plus the length of KJ, which you have not found. So the length, so the distance formula between K and J. So you'll have to do the distance formula one more time for KJ. Okay, and then you've already done the distance formula for the previous one. So once you get that, add all those together, and boom, that's your perimeter. Okay, and then it'll be units. Let's not do number 7. So don't do number 7. Okay, classify the triangle as scalene, isosceles are equilateral. So it's not going to be equilateral, okay? But, so that means that, remember, scalene, no congruent sides, so none of these numbers will be the same. Isosceles means two sides are the same, so one of them will be 6. Or scalene, where all three numbers are different, okay? So, classify as equal angular, acute, right, or obtuse. So if we look at this puppy over here, none of those angles look right or obtuse, so I'm going to go ahead and assume that, no, it could be equilateral. I don't remember the answer. But I'm going to go ahead and answer that it's acute. Okay, so you need the sides before that. Okay. All right, so if I did, it can't be. So let's see. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3. Okay, so yeah, it's not equilateral. Okay, but so it's not equilateral, but it'll be close. Okay, so that's not, it's either one of these two. All right, so that's what you'll do for triangle 2. So this is the part that I want you to take a picture of your work and put it in the slides. Okay, you do not have to do let's say if you don't do 8, okay, and then if you do number 7, that's extra credit. Okay. All right. Have a great day. Remember, this is for Tuesday and Wednesday. All right, because this is a lot going on. All right. See you later.